Hi there, ladies and gentlemen. Purpose of this video is to give students who are missed class an opportunity to get these copied down. Also, I might have gone too fast in class. I do know that some of you write faster than others. Obviously, this is an opportunity to fill in those gaps if I did go too fast, or simply if we did not have time to finish the lectures in class. You might have 5 or 10 or 15 minutes to finish them up at the very, very end. 2 rules for class notes. They got to be numbered. That makes it easy for me to scan them when you turn them in to see if you did 1 through 25 or 28 or however many there are. And they need to be in Cornell note style so I can easily see that you wrote down the question or the prompt and the answer. All right. If you are choosing to mute this video, totally get it. That's fine. The one thing that might be a disadvantage to is I will tell you when I'm getting ready to go to the next slide, but you, of course, can always rewind the video and go back if I went too fast. Yeah, I think that's about all I have to say about that. I will be flipping through the chapter and adding a few details that I cut out of the PowerPoint or simply did not include, because if I included everything, we'd just be lecturing 5 days a week, and I know you guys don't even like doing twice a week. So that might be a reason to keep the volume on, as you might pick up a few extra things while you're actually taking the notes. All right, here we go. All right, so chapter 14 deals with resources. So we're going to do some abbreviating. Non-REN for non-renewable. Resources is going to be RES. Even if it's resources, it's going to be RES. If it's a resource, it's RES. And the resources we're talking about are fossil fuels. So coal, oil, natural gas. Natural gas is methane. I'm going to abbreviate natural gas as NTG. Technically, nuclear is considered a non-renewable resource because the amount of radioactive material is finite and eventually it will run out. But one quick word about nuclear is that... Hold on 1 second. Never mind. One thing about nuclear is it's probably going to be an important transitional resource to get us off of fossil fuels and to buy us some time until we can get wind and solar and geothermal and biofuels up and running, because you do get a tremendous amount of energy from nuclear for a relatively small amount of material. And we're also getting better at figuring out where we're going to put the waste from nuclear. Okay, so net energy yield. Remember, energy is always capital E. Abbreviate high quality is HQ. So the definition, amount of high quality energy available minus the amount of energy needed to get it. I did just pause. I forgot that I do not have a copy of my chapter. Actually, wait a minute. I haven't brought chapter 14 to school yet. I think I still have all of my chapters with. Never mind. I'll shut up now. Okay, yes, I do have them. Sweet. I'm very proud of myself. I have 1 chapter of notes left to do. Just finished up chapter 19 last night. All right. Okay, Earth's surface, heat, and renewable. So renewable is going to be REN. Solar energy heats the surface of the Earth. Examples of renewable energy are solar, wind, geothermal, biomass or biofuels, and then also hydropower or hydroelectric power. As you can see, for the non-renewable, oil by far is used the most. Then natural gas is a close second, and then coal is third. And of course, oil counts as is what's used to get gasoline. So the globe is on the left. Same order. The only difference is there's more coal used than natural gas globally. Many developing nations, India in particular, have huge coal resources. And that's how the United States gained its prosperity: cheap energy. It allowed us to grow at a really fast rate, very inexpensively. And now, of course, developed nations are pointing their fingers at those other nations saying, no, don't burn your coal, don't burn your coal. And that's not really fair for us to do. So developed nations, we need to step up and offer assistance, new technology, maybe even lend money or give money to those nations to help them develop without burning all the coal. All right, moving ahead in about 5 seconds. All right, here we go. All right, so an example of net energy. So basically, to simplify it, net energy is energy output minus the energy input. There's also an example in the book. It's like the net profit earned by a business after it deducts its expenses. Or can you take it as a family? My wife and I have incomes that come in, and we have our bills are higher than we'd like them, but our teenagers are expensive. So whatever extra money we have left, we put into savings. So that would be our net energy or our net profit, if you will. All right, energy efficiency. So it's getting better. Getting useful work by using less energy. We're getting better at heating buildings. We're getting better at producing electricity. Well, better meaning not burning coal, oil, or natural gas to produce it. Driving more efficient cars. Back in the 80s, we didn't have electric vehicles. I'm sure that they were probably thinking about them, but I doubt that they were even designing them back at that point. Back in the 80s and 90s, gasoline was under $1 per gallon. So I'm looking at a diagram on page 422. And it's talking about net energy and fossil fuels. So cogeneration, which we haven't talked about, that's got a high net energy, means it's more efficient. Coal's got a high net energy. Natural gas is a medium net energy. Oil has a medium net energy. Oil shale has a very low net energy. So that basically means you're putting more energy into extracting them than you want. And when you do the math, you're not gaining as much efficiency. All right, moving ahead in about 5 seconds. And of course, that's about what I'm going to show you guys. All right. So pick two of each category. So electricity, space heating, high temperature industrial heat, and transportation. And I would urge you to pick some that maybe you wouldn't expect. These are the types of tidbits that you might have an opportunity to use on free response questions, not only for the practice ones that we do in class, but potentially on a test. On the test, beg your pardon. So gasoline's got a high net energy. Natural gas, methane, medium. Ethanol, where we get those from plants. Sugarcane, medium. Actually, you can get ethanol from corn too. Diesel, medium. Gasoline that comes from heavy shale oil is going to be low because the net energy for heavy shale oil up above is also low. Oh, there it is. Ethanol from corn is lower, which means there's way less sugar in corn than there is sugar cane. That kind of makes sense. All right, getting ready to bump ahead to the next slide. And here we go. Define net energy yield. That's back on number 2, if you can't remember. Yeah, so it's a subtraction problem. It's the amount of energy you get minus the amount of energy you had to put in to get the energy in the first place. Good. What are the 5 types of renewable energy? Might want to take back a look at number 3. Yes or no? Do you get your energy from any of those sources? You might not know. Most of you probably get your electricity from SMUD. Some of you might get your electricity from PG&E. I'm not really sure how it works on the other side of the river, over by Sac State. But if you do get your energy from SMUD, SMUD has huge solar fields. Okay, so you're getting clean energy. PG&E obviously is gas. That's methane. That is not renewable. Now my furnace, granted, my furnace is gas, but my electricity is solar. Okay, positives of oil. There's a ton of oil. Although most scientists estimate that we will run out of oil by about 2050. Well, pardon me. It's either 2050 or we have 50 years left. I think it's 2050. Let me see if I can find some details in the book. So we got a lot of it. We're really good at getting it out of the ground too. Negatives, it's got a low to medium net energy yield. Lots of pollution associated with not only the extraction process, but also, converting it into gasoline and also burning the gasoline. All produces pollution. Creates greenhouse gases. Climate change, we're going to abbreviate that as CC. It's got a high environmental impact, which makes it a lower net energy yield. Says we use an amazing amount of crude oil, the lifeblood of most economies, laid end to end. The roughly 34.7 billion barrels of crude oil we used worldwide in 2016 would stretch to about 31.7 million kilometers, or 19.7 million miles, far enough to reach to the moon and back about 41 times. Holy cow. All right. Moving on in a couple seconds. All right, here we go. Some vocabulary. Crude oil. It is what it says. It's crude. It's not refined. It needs to be refined before we can use it. Still searching the text to find out how long our oil is supposed to last. I know I could look it up on the internet, but I'm just shocked that it's not in the book. Maybe it is. I'm just not seeing it. So the 3 countries with the largest amount of proven oil reserves are Venezuela. Might not have expected that. Saudi Arabia. You would have expected that. And Canada. A lot in Canada is from, it's called tar sands, and we'll get into that in a little bit. In terms of production, Saudi Arabia, Russia, U.S., and consumption, the U.S. uses the most oil. 20%, China 17%, Japan 5%. All right, getting ready to bump ahead. So peak production is the time right before the oil well production declines. So it's basically when production is maxed out. So we use high quality energy to make products from the refining process. Remember, plastics come from petroleum. Rubber comes from petroleum. The asphalt that we put on roads comes from petroleum. Obviously, gasoline comes from petroleum. Petrochemicals are byproducts of oil refining. Petrochemicals, a byproduct means something that comes out of the reaction that you're not actually trying to get. But some of these byproducts can be used and sold. All right, moving ahead. This is what I was just talking about. So the easy to reach stuff is running out. Okay, I was wrong. Is about 50 years left. So when you guys are a little older than I am now, because I'm 51 right now, when you guys are in your mid to late 60s, we would run out. Hopefully, we stop using oil well before then and convert over to renewable resources. And get ready to bump ahead in about 10 seconds. All right, here we go. What are two positives and negatives associated with oil production? I want to take a look back at number 7 and 8. Yeah, so there's a whole lot of oil. We're really good at extracting it. Some other things that I didn't mention in the lecture, we're really good at refining it. We've been doing it for so long, we've become very efficient at it. Negatives, net energy yield isn't as high as we'd like it. Lots of air and water pollution associated with it, both the extraction, the refining, and the use. Climate change, greenhouse gases, and a high environmental impact, negative environmental impact. Negative associated with crude oil. Might want to take a look at number 9. Yeah, so we have to refine it, which adds cost and adds the possibility of more pollution. Why are gas prices in the U.S. and other developed nations so unstable? I want to take a look at number 10. First and second bullet, specifically. Yeah, so there's 12 countries that belong to OPEC. They control the global prices, supply and demand. If there is less supply and there's still a high demand, that's going to drive the prices up. If there is a larger supply and the demand stays constant, that's going to bring the prices down. But I'll be honest with you, I pay attention to these things. The cost of gasoline hasn't fluctuated much more than about $4.50, $4.60, $4.70, and like $3.90 in the last couple of years. That's relatively stable. Now, if you're driving a couple hundred miles a week in your commute, obviously that's a larger impact on you. But I only drive 7 minutes one way, so 15 minutes of driving for me to get to A and B. So it doesn't affect me as much. And of course, I don't pay attention as much as well. Moving on. All right. Commercial energy, 82% of our commercial energy comes from fossil fuels, mostly oil. We use more than we can make, which means we have to import it, and that makes the prices of gasoline more unstable. So our production peaked near 2020, which means that we're getting less and less per unit time, which means that we're going to have to import more and more this decade, next decade. Okay, pick 2 advantages of oil and 2 disadvantages of oil. I'm moving ahead in 5, 4, 3, 2, and 1. Heavy oil. We're going to abbreviate that as HVO. Shale oil. Shale is a type of sedimentary rock. And obviously, organic material is being, organic material is being pressed into this rock because we're getting oil from it. And oil comes from organic material. Gets trapped between the layers. So you have to pull it out of the ground. You have to crush it into smaller pieces. You have to heat it, which allows the kerogen to come out, and then you distill it, which is a way to purify it. Facts about heavy oil. Oil and tar sands. Lots of these in Canada. So basically, oil and tar sands, it's sand that has organic material in it. What you do is you use steam. I think steam makes the oil float to the top, and then you siphon it off of the top. And then, of course, you have to purify it and refine it from there. I remember, sorry for the yawn, I remember the movie Back to the Before the Flood, beg your pardon, Before the Flood, which we might watch in this class. DiCaprio is in a helicopter with a guy from, I think it's BP, British Petroleum, flying over a tar sands area in Canada. And he was saying that that entire region had been covered by a taiga, which is basically a forest that is in a really cold area. So they cut down all the forest, and DiCaprio says it looks like Mordor, from Lord of the Rings, just black, everything death, steam, nothing growing. Low net energy yield. You need a lot of water, fresh water, which of course is becoming less and less common on this planet, and it creates a ton of pollution. Primarily at this stage, water pollution. And obviously, after it's turned into gasoline and we burn it, and we're talking about air pollution in addition to water pollution. All right, moving ahead in about 10 seconds. All right, 5, 4, 3, 2, and 1. Okay, pick 2 advantages and disadvantages from heavy oil that come from tar sands or oil sands. says it takes 2 to 4 tons of oil sands and 2 to 5 barrels of water to produce 1 barrel of the heavy synthetic oil. This process also emits large quantities of air pollutants, especially sulfur dioxide, which can lead to acid rain in sulfuric acid, H2SO4, nitrogen oxides, which themselves are greenhouse gases and also can lead to acid rain when you have nitric acid. Particulates, of course, that's why our air is so bad right now. By the way, it's August of 2021, just in case you're watching this video in the future. And we've got a lot of major fires going on east of us right now. 20% more climate-changing CO2 than does the production of conventional crude oil, according to a study by the U.S. Department of Energy. Producing heavy oil is expensive, costs about $50 or more per barrel. All right, moving ahead in about 5, 4, 3, 2, and 1. Okay, what are 2 things you learned about U.S. energy consumption? You might want to take a look back at number 11. So 82% of our commercial energy comes from fossil fuels. We use more than we produce, which means we have to import it. And it looks like in 2020, last year was peak oil, which means that it's all downhill from here in terms of the amount we can produce in a unit of time. 2 positives and negatives about oil use in the U.S. Take a look at number 12. Yeah, some positives, lots of it. Net energy is medium, but it's decreasing because the oil all the easy stuff is disappearing, so it takes more energy to get it out of the ground. Low land disruption. Negatives, water pollution, environmental costs, release of CO2. It's vulnerable to international supply interruptions. 1 positive and 1 negative about heavy oil use globally. So you might want to take a look at number 15. So large potential supplies. We have not found all the reserves that we know are there. Easy to transport between countries. Efficient distribution system is in place. Disadvantages: low NEY, net energy yield. It's costly. Lots of CO2 and other pollutants. Lots of land disruption. Obviously, you're tearing off all the trees to get to it. Trees or other vegetation. Water pollution also. And lots of fresh water is needed. All right, moving on. So remember, NTG stands for natural gas. So methane is the highest used, then propane, butane, and hydrogen sulfide. You guys know what propane is. That's the gas that you use like when you go camping. Butane is the gas that is used in cigarette lighters. Hydrogen sulfide, I'm not really sure what we use hydrogen sulfide for, honestly. It's got a medium net energy yield. It's inexpensive to make. Burns cleaner than oil. It does produce carbon dioxide, though, which is better than the methane itself getting into the atmosphere. I think it's 25 times more potent than is carbon dioxide as a greenhouse gas. Can be used as a motor vehicle fuel. You actually can see some cars. It's typically in more rural areas. There were a bunch of cars, trucks primarily, that used it. You basically, it just looks like kind of a big propane tank in the bed of your truck. And it runs off of that. Okay, liquid petroleum gas, abbreviating LPG. Pardon me, liquefied. Low net energy. We export a lot of it. You got to pressurize it in tanks. You can move it around easily. All right, moving ahead. Okay, write down 2 good things about natural gas and 2 bad things. And again, I always urge you guys to pick things that maybe are not obvious to you. I don't want to assume that you know some of these things, but in any event, just pick some that you're actually doing new learning with. All right, getting ready to bump ahead in a couple seconds. All right, here we go. And I do apologize. These notes are really wordy, but there's a lot of information on non-renewable resources, obviously, because they're such an important part of our economy. So there is some talk about natural gas, being a transition fuel to get from coal and oil to renewable. It is cleaner. There are less environmental problems associated with it, but there's also some worry that if we start relying on natural gas too much because it is so inexpensive and because of its abundance, that might steer us away from converting over to renewable energy. So, getting the methane out of the ground, because it's a gas, it goes right into the atmosphere. Extraction, we're very worried about it just leaking out of pipes, leaking out of the ground. And if it doesn't get burned, it has a huge environmental effect with response to the greenhouse effect. I use a lot of water for fracking, produces a lot of hazardous wastewater. When you're cracking the actual rock crust, creates some earthquakes. Natural gas and the liquid solutions, wastewater can actually get into rivers, get into groundwater. All right, moving ahead in about 5 seconds. All right, here we go. WTF? No, it's not what you might think that means. So there's lots of videos on fracking, but this is a famous one where people in Pennsylvania, literally their water that's coming out of a well, they can light it on fire because methane has seeped into their water supply. So sometimes it actually seeps into their homes. And there are people that have to keep their windows open all year round so they don't have to worry about stuff blowing up. Okay, moving ahead in a couple seconds. All right, here we go. Okay, what are two things you learned about the use of natural gas? Let's take a look back at number 16, 17. Yeah, so it's comes from methane. It's got a medium net energy yield. It's cheap, burns cleaner than oil and coal. It's extracted using a process called fracking. Liquefied petroleum gas, stored in tanks, transported easily. Low net energy yield though, and the U.S. exports a lot of that. Good. Two biggest dangers of increasing the use of natural gas. It's an opinion question. I want to take a look at number 19. Yeah, so they're worried that because of how much it is, how much of it we have, and how cheap it is, that it might move us away from renewable energy. Um, on the flip side of that, there are many scientists that believe that it might be a good transition fuel. It's like, okay, let's use it in the meantime, but commit to some goals to be carbon free. And carbon is also methane, CH4, by 2030 or 2040 versus burning the existing coal and oil until then. If you're a homeowner in a fracking extraction area, what would you be most concerned with? And then a yes or no, are there more safe choices for U.S. energy? All right. So, yeah, your water lighting on fire, gas getting into your home, and your home catching on fire, blowing up. Yeah, there are more safe choices for U.S. energy. I mean, it's obviously safer to get your electricity from coal or oil, but certainly solar and wind work for most locations within the U.S. All right, moving on. All right. Okay. So this is the math connection. And again, you can paraphrase this. Also, you can wait, if, assuming you haven't written this down already or typed it up already, you can wait until you see the entire slide. You can take a picture of this. You can import it into your typed notes. I'm okay with that. Okay, here we go. So the givens, 1 calorie is equal to that many BTUs. BTU is equal to 257 calories. So these are your conversion factors. 1 kilowatt kWh is equal to 3413 BTUs. BTUs for coal are 9,800 per pound. Remember, 2,000 pounds equals a ton. And energy efficiency is calculated by dividing the energy produced by the energy consumed multiplied by 100. All right, so given all of that information, calculate the energy of a power plant that generates 64,423 megawatt hours of electricity by burning 31,796.825 metric tons, or 35,050 tons of coal. So again, pause the video, see if you can work this out. All right, pause it if you're still working. So you have to get rid of the megawatt hours, convert it to kilowatt hours, and then get rid of the kilowatt hours and convert it to BTUs. You have to have like units. Start with your tons of coal on the bottom, convert that to pounds, and then use that conversion factor. So this is basically a dimensional analysis on the top of the fraction, dimensional analysis on the bottom of the fraction to get BTUs and BTUs. And those two numbers divided by each other, multiplied by 100, are 32%. So that basically means that this plant is losing 2/3 of the potential energy as heat and only getting 1/3 of the energy. Okay, there was another math connection in this chapter. So half-lives. So waste still is radioactive. And depending on what the fuel was, the nuclear fuel was, will determine how long it would take for this radioactive waste to degrade to an acceptable level or a safe level. Half-life is the time it takes for half of a sample to become safe. After one half-life, half of the sample is safe. Kind of makes sense. After two half-lives, 1/4 is safe, etc., etc. Okay, uranium-235, which is a common nuclear fuel, has a half-life of 703.8 million years. Yeah, your jaw should have just dropped. Pick it up off the floor. So the waste that comes from this is going to take a really, really, really long time for it to become safe, which means that we need to find safe places to put it where it can't get into the environment. 1 kilogram sample contains about 4% or 40 grams of uranium-235. All right, here is the problem. Beg your pardon. Getting ready to bump ahead, so you might need to pause the video. All right, so after 3 half-lives, how many grams of U-235 are left? Give you a clue, you're starting with 40 grams. All right, here we go. So pause the video if you aren't finished yet. Okay, so half of that sample would be 20 grams, and then half of that sample again would be 10, and then half of that would be 5. So 3 half-lives, you're going to be left with 5 grams, or 1/8 of the original sample. All right. Also, there is a formula, 1/2 to the n, where n equals the number of half-lives. So you could do 40 grams times 1/2 to the third power, and that is 40 grams divided by 2 to the third power, or 40 grams divided by 8, 5, hence the 1/8 example before. Another example. Sample of low-level radioactive material has a half-life of 20 years and an activity level of 6 curies. After how many years will the activity level of this sample be at a safe level of 0.125 curies? All right, here comes the answer. So first half-life, 6 goes to 3. Second half-life, 3 goes to 1.5. Third half-life goes to 0.75. Fourth half-life goes to 0.375. Fifth half-life, 0.188. Sixth, 0.094, which is just below the 0.125 Curie. So it's going to be between 6 and 7 half-lives. All right, ladies and gentlemen, that is it for these notes. I will see you in class.